Hello and welcome to the first Numbergroup blog. I'm here today to go over a few items that we have come across in our day-to-day thing and also discuss some items that we think are important in the general sort of world today. And the subject of today's discussion is security and encryption. Now, normally these would be done with my colleague Johnny. Unfortunately, he's off on holiday at the moment, so it's just me for this week, unfortunately. But we'll sort of soldier on, and hopefully this will all work out fine. So anyway, introductions. I'm Ben. I'm the Senior Support Technician at Numbergroup, so if you have any technical problems and you come from the phone, you're more than likely to get me. I've worked in telecoms and so forth for a number of years now, and just imparting some of my knowledge onto the rest of you. So yes, we're going to go over encryption. So encryption and security mainly. So we're just looking at why encryption is important and why security in general is important. And I'm going to go through a few things. So encryption across our platform and how we support it, why it's important for you, and obviously why it's important for everyone really. And also going to go through a few things with regards to PBXs and handsets as well, because that's important to know about as well. Okay, so why is security important? Well, you probably well know about all the problems we've had recently with WannaCry, and you're probably sick to death of emails coming through about securing a network and securing this and securing that. But it's there for a reason, and this is one of the main reasons why security is important. But with regard to telecoms, well, okay, it's a bit more complicated than that. You can obviously encrypt SIP traffic. It's done via something called TLS, or Transport Layer Security, and obviously you can include SRTP, which is secure RTP, which is RTP being used is the protocol that's used to encapsulate and send the audio traffic. So if obviously you want to have secure audio traffic, you have secured RTP. Very simple. Now, obviously, without that, an eavesdropper in the middle can obviously intercept and decrypt your calls. So, standardly, most people transmit their calls via UDP. So, if someone sat in the middle and was sniffing the traffic that was being sent between your phone and our network, then obviously they're able to pick up the packets and decipher them and listen to your calls, which obviously you do not want. So, in order, how do you fix that? You literally just encrypt it. So, we supply a feature where basically you encrypt the calls from your phone through to our network. So, basically, anyone listening between you and us can't basically decipher what's going on. They can't intercept the actual SIP traffic, and they can't intercept and gather the encrypted audio traffic, so they can't listen to your calls. Now, why is this important, you might say? Well, I suppose the average person, it probably isn't very important, but obviously if you are dealing with financial stuff, and you've got confidential information you're discussing over the phone, then you may not want those informations out in the wider world and obviously available to whoever potentially may be listening in. So this is where encryption is important. So yeah, we obviously support that free of charge. That comes a standard with our trunking and our PBX products. As long as obviously the phones that you're using support it, then we support it as well. I will go through a quick demonstration of how to enable it on our portal, in case you're curious, in case this video scares you. I'm not trying to scare you, I'm just basically trying to advise, this is the situation we're in. So I won't go into too much technical detail about encryption because it is incredibly complicated, and to most people it really doesn't matter. As far as I'm concerned, you can go into the nitty-gritty details and so forth and explain, on a granular level how it works, but to most people it doesn't matter. If you really want to know more about encryption, Wikipedia, a good source. If you want to go through and how TLS works and the handshaking and all that jazz, then you can do that. It's up to you. I won't go through that with you today. I'm just going through the high-level stuff to basically advise you why it's important and all that. Okay, so how do we support it within Numbergroup? Okay, well, if you just have a look at the screen here, you will see that we are on the Lunar PBX system. And this is obviously what you see when you log in. When you log into your account, this is what you see. So, how do you enable it? Well, if you've got our supplied Grandstream handsets, you can enable it through the auto configuration system. So you can go to Lunar PBX, You go to the handset and you go to the handset you're looking to configure, and the encryption mode is found here. So by default we don't encrypt anything. The main reason being is because once things are encrypted we can't actually see it. So not even we can see your information or your data. So we can't really analyse it if you've got any problems. So, and in most cases when someone has a problem, it usually occurs at the start or just after they've been provisioned. So by default we always provide them, you know, unencrypted. So, but if you wanted to encrypt your traffic, you literally just drop down the list, change it to TLS and SRTP, save it at the bottom. No, don't deallocate it. You do not do that. You save it, and then obviously make sure that provisioning is enabled, so for the next time. And then when you reboot your phone, the phone will now be working using TCP or TLS and SRTP. Now, if you wanted to manually do it, so let's say you haven't got the handsets from us, and you want to enable it within your phone, we can do that as well. So we'll dive on over to my handset. In fact, if I could just put the IP address in first and not do a Google search, that would be fantastic. There we go. Get there eventually. So this is my phone. Let's say I want to adjust account number 2. So you would go to SIP settings, basic settings, and in here you've got SIP transport. Now obviously I've only got a grand stream here, so I can only go through that. I can't go through Yelinks and Snoms and everyone else because I don't have one. It's pretty easy within most soft phones. They will have an option there for TLS or secure or whatever, so just enable that. But in most phones you'll find it within the general sort of basic SIP settings. So in this, it's a grand stream phone. You go into the account, go to SIP settings, basic settings, and then you'll see there's an option there for SIP transport. You then just tick it to TLS TCP, make sure the SIP URI scheme is set to SIP-S, that's quite important, and then save and apply. Now the other thing you will need to do is obviously ensure that encrypted audio is being used as well. So you go to audio settings and you change the, and this is obviously where you get your codecs, you use the SRTP mode. You would really like to do it enabled but not forced. This basically means that if for whatever reason the recipient end are having some issues with their not licenses, what's the word? Certificates, that's the one. If you're having some issues with certificates and having issues getting the session enabled, it's allowed you to fall back to unencrypted. So this is probably the best way of doing it, but it will enable it. If the support is there, then obviously it will enable it, and you know. But most phones have multiple options, so you can choose enabled or forced or I don't know, or optional or whatever. It's really up to you. And then obviously just make sure you save all the changes you make, and then when your phone re-registers, it should then obviously be using, you know, SRTP and TLS, and therefore everything should be encrypted. You don't need to touch any of the other codec settings as far as the ground stream is concerned anyway. There may be some other things you need to do on other phones. Like I say, I can't really go into any massive detail here because I don't have the phones on hand to show you. But you know, I thought I would just give you a quick overview to see how you would do it on our own system or using the phones that we support and supply. So that is how you would do it on a ground stream anyway. So, but I'm just going to close that now. I don't need that anymore. Okay. So here's how you enable it. Now, what other security things can we talk about? Well, PBXs and phones. They're the most vulnerable thing that a hacker will go for if they are going to go for anything. I mean, yes, someone can intercept your traffic, and yes, they can try and get hold of information that way, but it's time consuming, there's a lot of effort involved, and so what people will normally do is they will go for the weakest point of entry, which in most cases is something that a human being controls. Now that would either be the phone or the PBX. Now, there are a few things here that obviously come into play and vary depending on your particular hardware layout or infrastructure setup. So I can't go over all the possibilities here. But let's just say you're using our hosted PBX system and you're using your own handsets. Now, most of the time people use a native connection, so they will not be open to the public. However, You can obviously use them on a non-netted connection, so they will be on a public IP address, which means they can be accessed from the internet. Now, over the years, one of the most common things I've seen is that people get into the phones from the internet because people just don't bother to change the default password. So it's very easy to find the default password. You just Google the default password for a phone, it will tell you. And then they get to the phone, they find the login screen, and it will usually say what brand of phone it is. And they just do a quick search and they just say, okay, well, I'll try admin, which is usually the default login, and the default password. And if it works, well, brilliant, they're in. Now, most times this isn't the end of the world, but in certain circumstances it is. For example, in certain SNOM phones, you can make calls from the GUI itself. And I had a case quite a few years ago where a third party had managed to guess someone had changed the login details on their SNOM phone. Someone had got in and used the web UI to make lots of calls to his premium rate number to generate him lots of revenue. And obviously you wouldn't know anything about it because the phone itself won't ring or anything like that. It's just done basically from within the phone straight out to his SIP provider. SIP provider would obviously only pick up if it was a particularly fraudulent way, like hammering the calls through multiple times, or the cost was creeping up, which obviously is how we detect fraud. So that way, it's not a particularly quick way of generating money for the fraudster, but it's a quiet way. And most people wouldn't realise that was going on until they got their bill through. So yeah, when you get a new phone, for God's sake, change the password to log into it. It literally takes a few seconds to do, and it can save you no amount of problems further on down the line. Same with PBXs, and even more so with the PBX. The amount of people I've seen who set their root password to password or something like that, and they've made it SSHable from the outside world, and they wonder why someone has magically managed to get into it and created an interesting dial plan within their PBX and then directed traffic through it to some weird and wonderful location, which has cost them thousands of pounds. It's fairly logical. A system can be as secure as anything, but if you make the password test or password, there's no point because it's only as secure as you make it. So even if you've got a fantabby-dozy firewall and you've got this and you've got that and you've got the most secure SIP system in the world and you've got everything else, if you don't secure the system, the devices you're using on it, it's a waste of time because someone will get in and just abuse it. So the moral of the story is, for God's sake, change your passwords and don't make them guessable. I know obviously the whole thing these days of remembering 1,000,001 passwords is a pain. A password manager does really help. I'm not going to suggest any because that's not what I'm here to do, but I would personally recommend you use the password manager. Obviously that won't necessarily help with SSH, but pre-shared key, it's not particularly difficult to do, especially if you're running some kind of Unix environment. So you don't even need to know a password. You just have your certificate already set up on the server, your SSH, it lets you in. And if your certificate isn't on the server, it doesn't let you in. Simple. And you can just disable the pass authentication. Problem solved. Only you can get in. Yes, I mean, it does mean that you're kind of limited to machines that have your SSH certificate on it. But I mean, if you're that mobile, you'll probably be using a laptop or something like that anyway. So you just put it on there and it will just work. And it just makes things a lot more secure for you. So, yes. But anyway, what else can you do? Well, just be sensible, like I say. Try not to do anything too stupid. Make your passwords not easy to guess. I mean, most of it is just logical. I mean, the whole WannaCry thing doesn't necessarily directly affect telephony. I mean, the NHS obviously was affected and their whole system went down, but the reason for that was just because their IT department essentially disabled their network to stop traffic because the worm just populates through the network without any need. So anything that's locally discoverable, the worm will just move across to it. So while it won't actually directly affect your phones, if your network's affected, then it will, because obviously the network goes down, your phones go down. Simple. So it's just a case of using your brain, being a bit more logical. So yeah, I mean, that's pretty much it. I know it's not particularly full of detail and so on and so forth, but this is the first one. This is the first blog that I should say, that we are doing. So it will be myself and Johnny in the future, and or Sham, any other team who wants to chip in and go over what the topic we're discussing. If you have any suggestions about what you'd like me to discuss or what you'd like us to discuss in these blogs, then by all means comment on the video and let us know. And then obviously if it's worthwhile, then gladly I'll do it. I'll go through it. If you want walkthroughs, guides, whatever, I mean there's plenty on YouTube already, but if you want any more or anything that specifically you think is missing, then by all means let me know and I'll get it done for you. So yeah, that's it for this week. I hope you found it instructional and informational. And if if you like it, please comment, thumbs up. It's all good. If not, then please let me know. It's the first one I've done, so it's a new experience to me as well. I'll try to improve, hopefully so. And so this is Ben signing off for now. And thanks for watching.